In the world of gaskets, it can be hard to find the right material for your project, especially when it comes to conductive gaskets. That's why in this video, we are going to cover what a conductive gasket is and what materials you should be looking for. A conductive gasket is a sealing component that also acts as a conductive medium for electricity or provides shielding from electromagnetic interference and radio frequency interference. These gaskets are critical in applications requiring both electrical conductivity and environmental sealing. Before getting into common materials, it is important to note that common materials may not work in your specific application. These are simply materials we see most often. The first material we will look at is silicon. Silicon gaskets are made from high-quality silicon embedded with conductive particles like carbon, nickel, or silver, transforming these normally insulating materials into conductive ones. These gaskets offer stability and precise tolerances, but tend to be rigid and dense with less elasticity than standard silicon. While effective for die cutting, the particle-filled silicon can be abrasive on tooling. Next are fluorosilicon gaskets, a variant of silicon containing fluoroelastomers. They are resistant to heat, solvents, and chemicals, making them suitable for extreme environments. They are excellent for conductive applications involving exposure to petroleum-based substances, but are less flexible and more expensive than regular conductive silicon. However, fluorosilicon gaskets are being removed from the market due to PFAS concerns related to these materials. Third, EPDM rubber gaskets, often infused with carbon black filler, are conductive and effectively dissipate electrostatic discharge. These gaskets are highly chemical resistant but vulnerable to hydrocarbons like gasoline and high temperatures, which can cause them to melt. Fourth is silver aluminum gaskets. They consist of a base material such as silicone mixed with silver-plated aluminum particles. This composition creates a conductive path that helps block electromagnetic interference. Due to their metallic nature, they often require higher sealing forces and are suited for electronic assemblies. Last is oriented wire gaskets, which combine silicon rubber with embedded mono wires, a nickel-copper alloy. The wires provide connectivity throughout the gasket and enable effective EMI and RFI shielding at lower frequencies, along with environmental protection. To determine the right conductive gasket for your project, start by clarifying the specific intended function of the gasket in its application. Identify what the gasket is designed to seal or protect, whether for EMI shielding, containing fluids, or protecting against environmental conditions. Also, decide if the gasket will be a permanent solution or a consumable part that requires replacement over time. Next, evaluate how the gasket's function will influence its requirements. Consider factors like the necessary level of electrical conductivity, the operational temperature range, and the chemical or environmental exposures it must endure. For applications involving pressure, define the pressure range and ensure the gasket can withstand those conditions. Additionally, determine if adhesives or mechanical fasteners are needed to provide structural support. Finally, focus on the design and physical characteristics of the gasket. Specify the shape, size, and thickness, as well as the ability to fill gaps or achieve critical tolerances. Define material properties such as the required hardness to ensure the gasket fits and performs as intended within the assembly. Addressing these considerations ensures the gasket meets the application's unique demands. Finding the right gasket for your project depends on your material, design, and the design's final purpose. Your conductive gasket will also need to be manufactured to your design specifications, which is where a converter can come in and help. Flexible material converters are here to help you source material, tweak your design, and manufacture your part. If you want to learn more about working with a converter, you can visit our Learning Center or reach out to us directly. Thanks for watching.